These are the solutions for the factor completely. Again, the odds are on CalcChat, but the evens here. For number 2, you should have gotten 5x plus 9y and x minus 2. Remember, order doesn't matter there, but the signs do. For 4, 2b plus c plus 4 and 2b plus c minus 4. The 4? Sure. Okay, so I'm going to first, let's write it over here, 4b plus 4bc plus c squared minus 16. So it's got 4 terms, right? I want to factor by grouping. I can take out a 4b here, and I get b plus c. Is that right? Yeah, because that's gone. And then the second one is actually the difference of 2 squares, and that becomes c plus 4 and c minus 4. Is that right? Yeah. C plus 4, C minus 4. So they grouped it. Where's the 2b? Oh, they grouped it as though this was one. Where'd the 4b go? Okay, this is what's happening. 4b squared plus 4bc plus c squared minus 16. This is tricky because this is actually the difference of 2 squares. That whole first one, we could factor it's a perfect square, and then 16's a factorable perfect square. So on the left, that trinomial, this is really tricky, but the left one, the trinomial, this is 4b plus c squared, right? This is a perfect square. Not 4b, sorry, 2b. 2b plus c squared. This is a perfect square. The square root would be 2b. This is a perfect square. The square root would be c. Wait for it. Wi-Fi, God. Yeah, there we go. Then you're going to multiply those together to get 2bc. Double it to check to see if it equals the middle term, and it does. So that is actually a perfect squared trinomial, which is why this is so tricky. You had to group them differently than we normally do. Then you would so that's a perfect square. This is my perfect square now, and that's the difference between them. So when I do difference of 2 squares, I would get the square root of this, which is just 2b plus c, and that goes in the first spot of each. Then the 16 is a perfect square. Square rooted, it's 4 and 4. And one gets a plus and one gets a minus. So I would say that's tricky because we normally see 4, and we want it like I did, right? And you want to factor by grouping. If it doesn't factor that way, look for other types of perfect squares, right? So if I group together those first 3 terms, it's actually the perfect square trinomial that can be factored further. All right, now where are we at? C is 6a plus 5 squared. That's one of your perfect square trinomials. 8 is, you can either say that that's prime, not factorable, something like that. They are both perfect squares, but there's not a minus between them. Yeah.
For 5, I know you said it was wrong, but...
The one on the initial PDF is wrong. So this should get factored further. They wrote plus here, which is wrong. Yeah, it should have been minus, and then that gets factored. So this is right. M minus 2n times this. CalcChat would have been right. It's just the PDF that the answers would have been wrong. Okay. And that's why it said plus, and it's minus, which then gets factored further. Okay, 10, take out the 6. It's 6c plus 2d and c plus d.
For 5, could you break up the p squared minus q squared into...
Yeah, you can go further with that. You could do p plus q and p minus q. Yeah, you would keep going.
Thank you.
You're welcome. So that overall answer, here, let me just rewrite it so it's easier to see, would be m minus 2n, and then p squared plus q squared, and then p plus q and p minus q. So it should be all 4 sets of parentheses. I'm assuming that's what CalcChat has. I didn't even check it. I just know the PDF was wrong. 12, take out the 3x, so it's 3x and then y plus 3x and y minus 3x. Once you take out that 3x, it's a difference of 2 squares. 14, we took out a negative n. Remember, you could take out a positive n too, and it would change those signs, but we took out a negative n to make life easier on the other one. And you'd get n squared plus 2n plus 3. Because they're both positive, you can't go any further with that. There's no factors of positive 3 that add up to positive 2. Negative would have been different. 16 is 2m and 2 minus m and m minus n. 18 was 5 times 4 minus 3p squared. Yep. 18? Yeah. So 80 minus 120p plus 45p squared. All of them are divisible by 5. So I'm going to start by taking out the 5. So you get 16 minus 24p plus 9p squared. It starts and ends with a perfect square, right? 16 is a perfect square, 9p squared is a perfect square, so I'm going to test to see if it's a perfect square trinomial before I go further because it'll make my life easier. Square root of this is 4, square root of this is 3p. Multiply them together, that's 12p. Double the product and see if it equals the middle, and it does. So this is a perfect square trinomial. To factor it, I square root the first term, I square root the last term, I take the sign from the middle, which is negative, put it in parentheses and square it. If you had gone through the long route with multiplying first times last and finding the factors, you'd still get it. It's just a way bigger number. Yeah.
Is 3p minus 4 the same?
No, the sign has to be on the 3, unless it's a negative 5 on the outside.
No. Can you like rearrange it though? So like the 45p.
You just have to be careful to put minus 120p plus 80, like that. Take out a 5. And it's 9p squared minus 24p plus 16. And then you can rearrange it. It is because it's squared. That would be fine. Because the squared's going to get rid of the positive and the negative signs. So that's fine. Yeah. Because it ends up in the same result. Normally, if it was just 4 minus 3p and it wasn't squared, that would not be able to be inverted. Does that make sense?
Yeah.
But whether it's that or the other way around, you'll always end up with the same terms because the first one's squared, which gets rid of the negative. Yeah, so that is fine. Yeah, sure. All right, 20 was, if you take out the negative 3x, that's perfect square trinomial, so it would be 5x minus 6y squared. 22x minus 2 plus 2y, and x minus 2 minus 2y. Yeah. Yeah. So this is another situation where it has to be rearranged. Let me make sure. The x squared, because when you group it, it doesn't work, right? Like I can't take anything out of there. I could factor it, so I could do, here, let me show you this. X squared minus 4y squared. Just see if this is another option. Minus 4x plus 4. So this is different to 2 squares. This would be x plus 2y, x minus 2y. And then plus take out the negative 4, so that's minus 4x minus 1. So if a term had repeated there, I would have pulled it out, but it doesn't, right? So this is another scenario like the one we just talked about, which is like a little bit trickier. You have to group these. Now this time, the order's not even in a way that's grouped, okay? You're going to actually do x squared. I'm going to take the negative off of the 4y squared, but it also takes it off of this and this. You can take out the 4. Let me see. Minus 4. Oh, I don't want y squared. I want x with it. Sorry. I'm going to rearrange it so all the x's are together. Minus 4x plus 4 minus 4y. So I'm going to group the ones that go, like I'm going to group the x with the other x squared, and I'm going to put the 4 with it because now it's a perfect square trinomial. These can be rearranged, right? Like all of these terms can be rearranged in any order that would make it work. So you have to pull the 4x with it, and then you have to pull the 4 over to make it a perfect square trinomial. Test it out. Square root square root, double the product, and it equals the middle term. So I factor the first term, I factor the last term, I take the sign from the middle, put it in parentheses and square it, and then it's minus 4y squared. Now that's the difference of two squares. So I get x minus 2y plus, this would be square rooted 2y, and x minus 2 plus, no, minus, sorry, 2y. So that one, like if you want to highlight them, I would say that that's a little bit harder than you would probably see. But that one and the one that we did before are the same type. When you group them, they do not factor. Yeah.
How would you like know that it had to be like the first three and then like the last one?
If you don't group them that way, you'd never be able to factor it into a perfect square. So if it's 4 terms and it doesn't factor by grouping, now you're looking to try to force it into a difference of 2 squares scenario, which means you have to look for a perfect square trinomial, which means they have to have the same variable, right? And the first and the last have to be squares. So you can kind of arrange it that way, a trinomial, so it has to be 3. So you know I'm going to try to find 3 that go together, that the first and the second, like when I do that test, it matches the middle term.
Would there ever be like one of those that's like not factorable?
No, not like this type. No, you would have to be able to get it that way. So you're either going to be factoring it by grouping in the 4 terms that you normally are, or you'd be able to get it this way. Yeah.
For number 21, why is it like K?
Because she wrote the wrong variable. That should be R. 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 All right, 24A plus B plus C times A minus B. 26x minus y, 2y, sorry, minus 2 and x plus 2y. 28m to the 4th plus n to the 4th times m squared plus n squared times m plus 1 and m minus 1. And 30, 16, x to the 8th plus 1, x to the 4th plus 1, x to the 2nd plus 1, and x plus 1 and x minus 1. So that one just kept going and kept going and kept going. Ask, yeah.
Can you do number
26? Sure. Okay, so again, it's 4, so I would test the factor by grouping first. Group and group. From the first one, I can take out an x. From the second one, I can take out a negative 4y. And I get y plus 1, right? Doesn't work out. Like, I can't take those out. So this is another scenario where I want to look for that perfect square trinomial. So the perfect square trinomial, this time I actually have x squared minus 2x and then minus 4y minus 4y. And if you look, you're trying to group together. Let's see what we can group together to get a perfect square. So if I do 4, we had before, there is no perfect square trinomial just to force there, right? So you have to look for other ways to group it in which it would factor. I just said, okay, x squared minus 4y squared is the difference of 2 squares. So let me try that. So I put those 2 terms together. X squared, well, let me do it without the parentheses first. X squared minus 4y squared. And then I would group negative 2x minus 4y. Now, if we factor by grouping, okay, that first one's different to 2 squares, x plus 2y and x minus 2y. And the second one, I can take out a negative 2, and I get x plus 2y. Now your greatest common factor is actually x plus 2y. And that can come out. And then gets grouped together, x minus 2y minus 2. Yeah.
Could you do number 30?
Mm-hmm. Okay, 16, x to the 16th minus 16. So those are both perfect squares, right? The exponent on the variable, if it's even, means it's a perfect square. We know 16 is a perfect square. So if I factor it, I get 4. This becomes x to the 8th, right? Because you're dividing it by 2. 16 divided by 2 would be 8 and 8. And then 4x to the 8th plus 4 and minus 4. Or you can take out a 16 from the beginning.
Yeah, that's what I did.
and you get x to the 16th minus 16, right? And then you can, minus 1, sorry. When I woke up this morning, I was like, I'm okay. I think my brain's functioning. I was wrong. Too little sleep for too many days. Okay, so now I'm going to break the x to the 16th up. That's still the difference, 2 squares. It would still be x to the 8th plus 1 and x to the 8th minus 1. Now, 8 doesn't look like it's a perfect square because by itself it's not a perfect square, but as an exponent it is. If I can divide it by 2, it's a perfect square.
So you wouldn't get the square root of it? Like x to the 4th?
Right, when you think about what we do with exponents, when we multiply them, we add them. It's different. So when you square root it, you're taking half, basically. You're splitting it in half. So this would stay because that's a plus. Oh, actually, that's a perfect cube. No, it stays that way. Then I would, Then I would take the second one and factor it into a different 2 squares. So now it's x fourth and x fourth plus 1 minus 1. The plus 4 stays as plus 4, but the minus 4 we can keep going with. X squared plus 1, x squared minus 1, and then again, still the difference of 2 squares. It's the never-ending factoring, x plus 1 and x minus 1. Now we're done. I would say this whole page is like challenge questions. These are not your normal factoring completely. Will you have to factor more than once when it's factoring completely? Absolutely. Will you take out a greatest common factor and then see a different 2 squares, or perfect square trinomial, or factor by grouping? Whatever that is, factor by grouping and then get a different a difference 2 squares and have to factor it further? Absolutely. The rearranging, I don't think we're going to be, we haven't, again, like I said, we haven't gotten to test on this at all. But you should be okay as long as you understand it. The factoring by grouping factoring completely will require more than one factoring, but not usually the rearrange. Yeah.
Why do you only keep the difference of 2 squares at the end?
It doesn't matter where you put them. Is that what you mean?
Negative. Like you get rid of it for the rest of the equation, but at the end you keep it.
It's not that I'm getting rid of it. It's that so only the minus can get split. So this minus got split into this and then to this, and then this minus gets split into this, and this one into this and then to that. Yeah, so all the plus can't get split, but the minus can. Kiara?
I have one more question.
Yeah.
21.
21. Is that on this page? Yeah.
You said it was the wrong variable. What happened to the other variable?
Oh, wait. So this one should be, I wrote on top of it. Let's just work it out. So we're grouping and pushing this to the end. And then it's the different, this one becomes r minus 3 squared, right? Because it's perfect square trinomial, minus 9s squared. This should be r minus 3 plus 3s and r minus 3 plus, minus 3s. That's what it should be. I think that might be a completely different, like an answer for a completely different question. This is what you should have gotten. Yeah, you're welcome. So that's another regrouper. I look for the variable that has the squared and the non-squared, and then I pull the constant with that one. That's what I'm looking for. When I look at this, I have r squared and negative s to the second. Those are both squares. I could put them together and try to do the difference of 2 squares. But then I've got negative 6r plus 9, which may not factor out. One's going to have, the beginning's going to have the s and the end's not. So then I try to see if I can make a perfect square trinomial from the squared and the variable that has the coefficient and then the constant that's by itself. That's my approach on those. Again, I know they're tricky. Don't freak out if that's something that's you haven't mastered. All the other types of factoring you want to make sure you know how to do, especially because they're built into what we did last night and what we're about to do. All right, so this section is P5B, which is multiplying and dividing rational expressions. So we're going to literally add like an extra step to what you were doing before yesterday. If you understand how to factor and cancel out, then you should be fine. It's a little bit more, like 1 or 2 more steps depending on the different kinds, but that is the basic idea behind it. So you're going to get, it's called rational expressions because it's fractions again. You're going to get either a multiplication or a division statement. There's technically 4, if we start with just the basic, 4 parts to that. There's the fraction on the left, the top of it, the fraction on the left, the bottom of it, the fraction on the right top, the fraction on the left, on the right bottom. You want to factor all of those spots if you can. So you're checking all those. So it's a lot of factoring, which is why you got to get really good at it. You're going to factor all those spots. And then with multiplication, we can either simplify the individual fraction like you did yesterday, or you can cross cancel. So if I had something like, let's just take it to the basics, right, without even factoring. If I had 2 over 5 times 25 over 4, what can I cancel here? I can do 5 into 25 is, this would be a 1 and this would be a 5, right? And 2 and 4, this would be a 1 and this would be a 2. And then I would multiply out what's left straight across and I'd get 5 over 2. So the same concept is going to happen today, except these are going to be expressions like x plus 2 over x plus 3 times, and then you're going to have to factor something, but let's just say it says x plus 3, x plus 1, and then x plus 2 squared. Let's say that's what happens after we factor it. So we're going to have a step where we have to factor it. You can cancel top left and bottom right, top right and bottom left. What you cannot cancel is a cross. I can't cancel 2 in the top or 2 in the bottom. So I can say, okay, I can take away one of the x plus 2's, and I can cancel out the x plus 3, and what's left is x plus 1 over x plus 2. So that's the general idea. We're going to have to factor first, and then we're going to start to cross cancel. If it's dividing, we are going to take our statement, stay, change, flip, and then do the same process. So if you see a division bar in between, then you know you have to stay, change, flip, or keep, change, flip, right? Keep the first one the same, change your sign to multiplication, flip the second fraction, and then do the same thing we just did. Factor all the parts and cross cancel. Okay, so look at number 1. The first thing, again, you need to do, first of all, this is multiplication, so there's no keep, change, flip here. Then we have to say in all these 4 parts, so there's numerator on the left, there's, bless you, numerator on the bottom, numerator on the right, numerator on the bottom. What of that can get factored? Good. X, say that again. Well, factored. What's like squared on there?
Oh, x squared.
Good. X squared minus 9 becomes what? X plus 3, x minus 3. Difference of 2 squares, right? Now remember, you can only cancel a whole expression with a whole expression. I can't do this. Wrong. Cannot. This is a little protected partnership. This can only get canceled with exactly that, or its opposite. This can only get canceled with exactly that. So those two do not cancel. This x plus 3 can only get canceled with an x plus 3. Do we have another x plus 3? Yes, top right corner. Those can cancel out. So we can cancel diagonally or top and bottom. We can't cancel left to right. Now what's left in my numerator is x minus 2 and x minus 3. And in my denominator, just x plus 4. All right, look at 2. What there can be factored? Same thing, x squared minus 9, x plus 3, x minus 3. Can anything else be factored in any other spot? No. Now we look for canceling. Can I cancel what? So the x plus 3 from here can get canceled because I can cancel top and bottom, like what we did in last night's homework. And x minus 3 can get canceled across here. Now all that's left in my numerator is x plus 4. Nothing's in the denominator. You could put it over 1, but it doesn't matter. Questions so far? Okay, this is when I said you have to know your factoring, this is why, right? It's going to put all different kinds in there. That was different to 2 squares, but it's going to blend them all together. Not like the last page of your homework last night, but the rest of the stuff, or from 2 nights ago. Look at 3. 4 different parts. Take them one at a time. Can the top left be factored? We got to at least try it, right? So 3 terms, not perfect squares at the front or the back, which is when I'm going to do first and last. So I'm going to do 2 times negative 6, that's negative 12. I'm going to look for factors of negative 12 that sum to positive 1, which are what? Positive 4, negative 3. I'm going to replace the middle term with them. And then factor by grouping. Take out a 2x. Take out a negative 3. Inside the parentheses is the same. And what's outside gets grouped together. So x plus 2 times 2x minus 3 is the factored form of the numerator on the left. How about denominator of the first fraction? How do we factor that? You can do first and last, but there's a 1 here, right? So I don't even have to account for that, but that, of course, works still. You could do first and last. Because it's a 1, I can just look for the factors of negative 5 that sum to positive 4, which are 5, right? Positive 5. Positive 5, negative 1. Now we go top right. What do I do there? What's the greatest common factor? X. Take out an x. Now what? Are there factors of 2, positive 2, that sum to negative 3? What are they? Good. And bottom right. What do I do there? Okay. Oh, this should be 2x. 2x minus 3. Okay, so now we're looking at all 4 factored spots, right? And remember, we can cancel top and bottom, or we can cancel left to right. So the factored form of the top left was this, top right is this, bottom left is this, bottom right is this. What can I cancel out? Richard. 2x minus 3 from the top left and the bottom right. Good. What else? X minus 1 top right, bottom left. What else? No, good question. So they have to, if they're opposites, remember, they both have to have a minus, but the variable and the number switch. So we could do it if it was x minus 2 and 2 minus x, and one gets a negative 1. But if one's a plus and one's a minus, you can't. But there is something else left there that we can cancel. Good. Go back to basics, right? In my numerator, my denominator, they both have an x on the right. So I can actually cancel out x and x. The 2 stays, but the x is gone. I can only do that because it was multiplication. If that was 2 plus x in the bottom, I could not do that. Only because they were both multiplication. So now in my numerator, I have an x plus 2 and an x minus 2. In my denominator, I have an x plus 5, a 2, which goes at the front. Yeah. So if I think there's a question that has it, but if it was this, is that what you mean? Yeah. This gets canceled, and it's literally -1. If there's more terms, you could literally put the negative in the top, you could put it in the bottom, you could put it out front, as long as there's a negative there. I think they're built into the examples, though, if I remember correctly. You're welcome. So here's the other thing. Let's say we didn't catch that x, let's say we left it there. When we went to go write what's left, I would have had x times x plus 2 times x minus 2 over 2x, x plus 5. And hopefully you caught it there. It's never too late, right? You can catch it after you combine it. It's just that you want to catch it, okay? So again, if there was a variable on the top and bottom, or if there was like a number there, if it was like 2 and 4, 2 goes into 4 when it's by itself. All right, look at 4. The 5 goes into 25, so this would be 1 and this would be 5. X minus 1 and x minus 1. So there's actually nothing to factor in this one. We just did a lot of canceling. Numerator, nothing is left. That doesn't mean it gets a 0. It means it gets a 1. Denominator, the only thing left is a 5 and an x minus 2. Questions on that one? So here's what I will say about the homework and when you're working through stuff like this. Maybe number 1 is really difficult for you, but 2 just clicks. Never give up. Never get to like number 10 is hard. I'm done. I'm not even going to keep trying. Because sometimes stuff like what just happened is happening. It doesn't necessarily always go in harder, easiest to hardest. So always, like if you're stuck, always try the next thing. When you're doing this homework, you cannot just give me an answer, okay? And I need to see all the factored forms. And even if you can't get something to cancel out, try to factor each spot, okay? If you get frustrated, at least factor it. Look for common things. Obviously, that's the goal. But if you can't get to it, at least give me the factored form of it. All right, 5. I think, yeah, and then we're going to switch to division. Good. Okay, so 5. All right, did we factor correctly? X minus 3 and x plus 2 in the top left. X plus 3 squared, or x plus 3 times x plus 3 in the bottom left. X plus 3 doesn't get factored, but then x squared minus 4 is x plus 2 and x minus 2. Now what? Go ahead, Carrie. So top left, bottom right, x plus 2 gets canceled. X plus 3 and the x plus 3 here, and one of these, right? So if you kept it in factored form, you just squared form, you just get rid of the exponent. If you have both out next to each other, you can cross through one of them. Anything else? No. So in the numerator, I get x minus 3, and in the denominator, I get x plus 3 and x minus 2. Now, I know I teach math for a living, which makes me a complete nerd, but I get so excited when you start to be able to cancel stuff out. I hope you will too. Like when you get to that 7, you're like, yeah. I mean, I'm not going to do it for fun in my free time, but you know what I'm saying, right? Okay? That's when it starts to feel good. Yeah.
Can't you cancel x minus 3 and x plus 3?
No, only if they are both minus, but the signs are, but the variable and the number and the number are switched. So if it was x minus 3 in the top and 3 minus x, that's the opposites. That we can do -1. One's plus, one's minus cannot be canceled. Yeah.
So it can only cancel -1 if it's negative?
Right.
If
So if it was x minus 3 and 3 minus x, that can get canceled.
So if it was x plus 3 and 3 plus x, it won't work.
Oh, plus is fine. Yeah, because order doesn't matter. I just mean 1 plus and 1 negative. Yeah. So x plus 3 over 3 plus x cancels out completely. The plus means it can be in any order. The minus is where it gets tricky. Okay, so 6 now says divided, right? So obviously always look for it. What's the sign in between? Because they mean two different things. The divided by means I'm going to flip it. You can choose to factor it and then flip it, or flip it and then factor it. It doesn't matter, okay? 2 types of people in the world. You get to choose what you want to do. I flip then factor, because sometimes you have to write less out. So I'm going to do x to the third minus 8 over x to the second minus 4. Keep means keep. Change means the division becomes multiplication. You could put an x or you could put a dot, your choice. Flip means take that last fraction and literally flip it, make it its reciprocal. So x to the third plus 8 over x squared plus 2x plus 4. With me so far? Now we factor. What's the top left? Perfect cube, right? This is the long one. So cube root this, I get x. Cube root this, I get 2. Then it's x and 2, x squared, 2x, 4. So cube roots of each. Then the square of the first one, the product of the two, the square of the last one. And what's our acronym for our signs? SOAP. Same, which is minus. Opposite, which is positive. Always positive, positive. Bottom left, how do I factor it? Good. Difference 2 squares. X plus 2, x minus 2. Top right. Good. Perfect cube again, but this time the signs are different. It's the same exact expression, just flip your signs. So x plus 2, x squared minus 2x. The last one's always positive, so it's still plus 4. How about bottom right? Can't do it. Factors, there's no factors of 4 that can sum to 2, right? Now's the fun part. What can we cancel out? X minus 2 in the top, x minus 2 in the bottom. X plus 2 in the top right, x plus 2 in the top, on the bottom left.
And then x squared plus 2x plus 4.
That whole sucker. X squared plus 2x plus 4 with x squared plus 2x plus 4. Only thing left is x squared minus 2x plus 4. Kiara.
For the one that was like x squared plus 2x plus 4.
Yeah.
And you said we couldn't factor it. Why couldn't we do like x plus 2, x plus 2?
Because the middle term would be 4. Right? Yeah. Does that make sense?
Yeah.
Always check it. Because if I multiply that out, right, that's 2x plus 2x, which is 4x. How we doing? Yeah. Kevin.
So you can like cancel out the numerator and denominator if they're the same exact.
Yeah, just like what we did yesterday, think about, right? They only had one fraction, so you can simplify. What you can't do, again, is this with this. Like I can't go, well, obviously those are opposite signs, so I can't do it. But I can't go left to right. I can go top and bottom, and I can go diagonally. You just can't go both numerators or both denominators. You're welcome. All right, let's see how many of these we can do. Yeah, do as many as you can. Yeah, we'll see what we can get through.